Clifford Carnicom, thank you for joining us today. We're going to talk about some extremely important things that are a culmination of 20-something years of work, 400 research papers, and almost 5,000 pages of notebooks to support that research. All available on your website.
CarnicomInstitute.org, yeah.
CarnicomInstitute.org. CARNICOM, institute.org. And everything could be downloaded in PDF form as well. You and I have spent some time together. I've had the honor of going over basically every research paper with you, including the most recent 6 papers that's going to be the main topic of discussion today. But just to summarize for a minute what you've done, you have basically looked up in the sky 20-something years ago, saw these streaks that were not contrails. You became curious about what they were because you saw the atmosphere transforming before your eyes, something which people today don't even maybe admit or realize. And you said, I want to find out what this is. And you taught yourself what you needed to learn, 15, 20 different kinds of disciplines involved with analysis, scientific analysis. You basically discovered that there were metals, there are metallic salts. Most important, you found out that there are biologic agents, biological entities being sprayed in that stuff that they were spraying. And you spent many years looking at it to find out what it was. And you discovered a bunch of components, but in the end, you found something that you described as a cross-domain bacteria. Cross-domain because it involved characteristics of the 3 major domains of life. Also because it was spherical, like a coccus bacteria. It exhibits not just aspects of what bacteria exhibit, but other things as well. Then you started to look at the world around us and say, well, where else are these things? And you found them basically everywhere you looked. You found them in every person's blood that you looked at. You made solutions out of them that we found out were toxic to plants and other life. You found them in some animals when you looked. And you came to the conclusion that this submicron-sized cross-domain bacteria that you named was the fundamental particle behind a transformation that was happening within our bodies and within this planet. So would you agree so far with everything I've said?
I would. I think that's a fairly, certainly more concise summary than I would be able to provide. Yes, it's all true. And I want to thank you for taking the time to become familiar with the work, because it's actually sort of interesting to say that that kind of volume of body of work exists, and yet ultimately a single small biological entity becomes a true focal point of that work. Something seemingly small, seemingly possibly minor in the scheme of the size or scale of life, actually ends up becoming a true focal point of the entire body of work.
And what I would say is remarkable, not only what you had to learn to do the type of analysis that you did, but the imaginative approaches that you used also to study this thing with relatively very little resources, especially to start, and then getting what you could to do some very, very detailed analysis that now the world has to look at. And you've always invited the world to look at it. You've invited the world to try to refute it, to add to it, to do the other types of research that through all of your papers you've recommended needs to be done and should be done. But now we have some even more amazing findings in a way. Because one of the foundations for doing your work was culturing. And cultures are things that biologists use and I imagine other scientists too, but in particular biologists, to grow things. And you've used many different culture mediums to see which one does the best job of growing what you want to see, well, or what there is to see. And what you end up with is finding stuff that's in the blood and growing that stuff outside of the blood so that you can examine it more. But as I was looking at your work, and I think I even mentioned it to you, I said, you know, what better culture medium is there than the blood itself? Because isn't that where this stuff is growing and living and doing its thing and causing havoc? It's not like it's doing anything good for us that we've been able to find out. So you did something pretty amazing. You learned a whole new discipline, electrochemistry, which has many, many different techniques within it that you can use. And you picked several of those that you felt could be the most productive, but also the most accessible for you, given your resources and given the equipment that you had, which was very innovative that you put together. And basically what this does is it puts a current into whatever you're looking at. Mm-hmm. So you put a current into the blood. And it was basically blood with just distilled water. So it's about as pure as you could get as a medium. What you found out was that
human blood, I guess we should say.
Human blood. And what you found out was that by carefully manipulating current, voltage, alternating the polarities, you were able to do what electrochemistry does, which was identify, it basically gives you a fingerprint like all these things do, that you can then go to the books and say, okay, well, what does this fingerprint mean? You can find out, okay, well, here's the constituents of what we're looking at. But what it did was it supercharged the growth of these cross-domain bacteria and filaments, which you'd seen many times before, rarely in the blood. This supercharged the growth of these CDBs and the filaments within a very short period of time with a minimal amount of current, so that it basically took over. And in addition...
in fact, I use the word transform. I use the primary title of the paper series. It uses the word transformation.
Right. So we got blood that's being transformed into
It's been changed. Yeah, it's been changed.
These other things, which raises an amazing question then you asked. Okay, if a little current, and we're talking about 0.1 to 0.2 milliamps.
Yes, the exact range is going to be uncertain. A very safe number would be 1 to 2 milliamps at this point.
But that's what you use, so it could be less than that.
Absolutely, could be less and could be significantly less.
Right.
Because of the dilution factor.
Because of the dilution. I think in one of your papers you mentioned it could be a factor of 10 less.
Easily. Could be 100. Could. Okay. 1,000 is not
but
out of bounds.
Even to think that 0.1 milliamps could cause this transformation, radical transformation within a short period of time, and that's all that it needed to do it, is pretty astounding.
And by the way, in terms of scale, somewhere in the range of, let's call it 20 to 60 milliamps is where things start to get harmful and potentially lethal.
On its own.
Yes, it doesn't take too much, but nevertheless, just to put that in context, that normal reference frame is maybe on the order 20 to 60 is where you'd start to have concern about human viability in life. So we're talking something that's a mere fraction of that producing this type of change.
So then you said to yourself, okay, well, we know about Maxwell's equations that basically shows the relationship between magnetism and electricity. Magnetism can create electricity, and electricity can create magnetism. So you asked, okay, well, we have a magnetic field within our own body. We know we have an electrical field within our own body. So to what extent do those both fields, at the magnitudes that they operate, could actually be compounding this effect and nurturing this transformation in itself?
Right.
But then also, if we're a magnetic field working that goes through electrical fields, or we're an electrical field that goes through magnetic fields,
Yeah.
are there electrical fields and magnetic fields around us that could actually serve a way to turbocharge this transformation? And well, yes, they're all around. And in your papers, you document maybe 10 or so.
14 are in there.
14.
And 15 comes to mind, but I didn't.
Right, and
write it.
and you said to me, there's probably,
Yeah, there's
a huge amount of others.
Yeah, the list could go on and on.
Whether it's a cell phone, whether it's the use of HARP,
Satellite technology,
Right.
ground wave,
it's all around us.
specific direction of energy deliberately. I mean, there are many, many options.
Okay. So there's plenty of opportunity for these fields to have the type of effect that you created in the lab, but even to a greater effect. To a greater effect where you have concluded that there now is probably in place a kill switch. That if the intensity was raised enough for an electrical or magnetic field, that it could wipe out all human life on the planet.
I was confirmed enough in the work to use the phrase kill switch, which wouldn't be my, let's say, normal instinct, but the circumstances justify the term and the language that's in that paper, and what you say is accurate.
So when you look at this as a scientist, you realize there's nothing random about this. This is a design. There's a huge amount of design, there's a huge amount of forethought that's gone into everything that you've observed. Would you agree?
Oh, yes. The history is actually closer. Most people don't realize that the actual history goes back close to 30 years. There is a continuous progression in the world of science of pattern recognition and scientific analysis that leads us to where we are. There's a long history now behind it, very substantial history of work, and the work is all consistent. It would be impossible to make an argument of it being any type of random event. It's absolutely a system of design, quite sophisticated, comprehensive, really at the grandest scale that you could think of.
One of the things that you did is you looked at 4 samples of live blood. Now that's significant in itself, because before, in almost all the previous work, you were using slides with dried blood on them. But then what you were finding out, and which was about the time that the whole COVID op was happening, that you were having more difficulty being able to separate things that you wanted to see using that technique. So you decided, I think we need to now move into looking at live blood.
Yes, because time became a factor to determine the amount of time required to produce essentially a problem. The problem being one of coagulation in the blood.
So basically, because blood was coagulating so quickly, that was creating a problem for you when you were trying to do the dry slides.
There was, at the time of dry slides, it was the reason for it would not really be clear at that point, other than the slides are not behaving in an expected fashion, and fluidity of the blood would be the question. And so live blood analysis is the more logical approach, because time becomes important. Seconds become important.
So in your papers, you took the blood from 4 people. You looked at it over time in 2-minute interviews, 5-minute interviews, and so on, and you saw a transformation in terms of the rate of coagulation.
Right.
You saw
The act of coagulation alone by itself would create a great deal of concern. Just the act of coagulation in the time span that we're speaking of. Literally seconds were involved when the process began.
All of this blood was from unvaccinated people, or these unjabbed people. It's not really a vaccine. The unjabbed people, and people who had not been in contact for any extended period of time with folks that have been jabbed, correct?
Right. And that's really by circumstance. That wasn't even actually planned. First of all, I'd like to mention that when we talk about, these 4 samples, there's also a history that precedes it of 25 years where, ultimately scores those samples would be. It was a continuous process. Blood observation and an evaluation was a continuous process
Right, and
over that 20 years.
And this basically confirmed your findings of 25 years.
It's all consistent with it, other than it adds on an entirely different dimension to it. And there's a gap in time where we had this significant societal event take place, namely a global vaccination program. And without passing judgment on that, there's an obvious question that arose in comparison to that previous history, and that was there any sign or change in blood behavior in the elapsed vaccination program, that 2 to 3 year window, relative to that 25 year history. That was a motivating drive behind this project. The very first stage of the work, this work has 6 stages that we would talk about if time permits. The very first stage of that work showed a real problem with the coagulation issue, and it was really completely unexpected or unanticipated, particularly since it was now known that this particular sample set did not involve individuals that had, quote, vaccinations. So it actually simplified things in terms of it removed something that could be important in a consideration. With that not even part of the consideration, you still had a very substantial issue come up staring you in the face, that this blood is showing a marked difference, and a dangerous difference, ultimately in the end. There's no way you can deny that, relative to that previous history of 25 years. That's just the opening stage of this work. And then if we have time, we progress through the various stages and series of these papers. But you start out that we look to have one serious problem here, and you don't even need to talk right now about the global operation of almost compulsory vaccination. Not quite, but pretty close.
On those
pretty
individuals that had been vaccinated.
Yes,
because it's almost like there was a global effect independent of the
vaccination. We have many questions we could entertain. And we haven't even got to the point where you're actually considering the question that was driving the work. But you have enough on your plate with the results of this research and those papers to basically blow the lid out of anything at all that we thought was a problem. We've got a much bigger problem.
So the problem is coagulation at a rate that you had never seen before, and to an extent that you hadn't seen before. By the same token, you're still finding the CDBs as much as ever. You're finding now more filaments in the blood, which you hadn't seen before, but much more filaments. And you're still finding these proteins that are associated.
Yes, what I would suggest is we try to then step through these papers a little bit and try to get through these 6 stages so that we realize the contribution of each one of those stages to the work. Because it's not that I'm just finding more, it's that a stage of the work produces. That word transformation is important. That's not a light word to use. When you're transforming something, you're changing something. And you don't want to be changing blood. You don't want to be dealing with something that's transforming blood. So I think it behooves us, at least in a summary form, to try and get through these stages and realize it's not just more of something, it's a series of actions that caused something to happen that is completely unanticipated. And the earliest stage of it produces a problem by the world of logic should involve an immediate response from the entire global community regarding health, let alone the other 5 that we'll get into as time permits us. So the first one was that, and maybe you can help guide that series, but we're at number 1 right now, where we have an observational set that shows a problem with coagulation, right? And it might be beneficial if you can help drive us through that series in the time period we have, to try and have that composite picture of what happened in this entire set of 6 papers and the time that, that I spent in the effort to make them available.
And we're going to do that now, but what I wanted to do is to have a relatively short introduction that gave an overview of your work, this most recent work, and also the issue that it revealed.
Yeah.
And now that we've done
good.
that, we'll go take a look at this stuff in more detail, and then hopefully people can follow up by going to your site and reading the papers themselves.
Great.
So Clifford, the first thing we'll do is look at the website, carnicominstitute.org, carnicominstitute.org. And we're going to see, where do we find these 6 papers that we've been talking about regarding the alterations in the blood, your most recent work? Well, it's right on the first page here. Here's 5 and 6. Here's 4 and 3, 3 and 4, and here's 1 and 2. Or you can go into this tab here, Research Library, that has all of your papers, including the 400. And right here, we see them, blood alterations 1 through 6. We're going to go take a look at number 1. And it's titled Coagulation. And we'll start here. And we've talked already about the fact that the blood that we're going to be looking at is from people that have not received the vaccine or the jab. They have not been around people that have been jabbed for the most part. And they are of various ages, and 2 are women, 2 are men. This slide here represents what is we find in a textbook as normal-looking blood. Now we're going to see on the slides that we're going to look at as a different color. Don't let the color bother you. We just want to take a look at things like the separation between these cells. They're very well formed, well defined, and circular. Okay, so now let's just take a look right out of the box now. This is the first male, 69 years old. This is at 2 minutes. Okay, so we're going to see a progression here. This doesn't look anything like the normal cells. They're misshapes, they're coagulated, and there's different forms of words that they use to describe some of these things, like roulet and so on, agglutination. But we're just going to refer to all of it as coagulation of some kind. And after 2 to 5 minutes, we see even more so. And this black thing
That's
is
just a dark spot in the lighting.
Okay.
It's not any
and
physical object.
here even more so after 5 to 10 minutes. Okay, we've got a female, 74 years old, right out of the box in 2 minutes. We see a lot of coagulation, more so after 2 to 5 minutes, and then 5 to 10 minutes, even more so yet. Here we've got a male, 71 years old, a decent amount of coagulation, but then also a fair amount of misshapes. And of course, everywhere we look, we do see these CDBs. And we're going to have a blow-up of what those CDBs look like. These little round things, but they're there, that's for sure. Here, the coagulation doesn't increase perhaps that much. It's about a steady state almost. But we can see the various kinds of coagulation that are there. And then here, we have a female that's 62 years old, and it's almost horrifying the condition that the blood is in, right out of the bat. And even over time, I guess it gets a little bit more coagulated, but it's so bad to begin with. Here you define what these various ones are. It might just be worthwhile to take a look at it. Rouleau is the characteristic of blood cells aligning themselves in rows or chains, or is caused by an increase of plasma proteins in the blood, such as fibrinogen or globulin. Agglutination is the random and disorganized clumping of red blood cells, and it's caused by formation of antibody-antigen complexes. Coagulation is the process by which a blood clot is formed. It would seem reasonable to presume that all 3 phenomena are likely closely related or associated with one another. That's why I felt comfortable kind of just referring to them all as one. And here you go into subject 1, you describe what you see, which we've kind of done. And just of note in 4, subject 4, is a 62-year-old female. The condition of this blood sample from the onset to the end of the observation period appears devastating. That's a word you use. Combination of extreme geometric breakdown, massive QDB presence, and continuous agglomeration is evident. It is difficult to conceive of the blood in this sample being able to satisfactorily perform the functions required for health. And here's a blow-up of one of those clumps of red blood cells where we see these distinct little round cocker-shaped things, and those are the CDBs. And if you blew up, this is 6,000 magnification, the rest was 1,500. And if you blew up any one of those places, you would see the presence of these CDBs. Some of the analysis that you've done was only on one sample when we get to some other papers because you wanted a consistent sample to be able to draw some conclusions from it. But here, you'd say, well, wait a minute, these are only 4 samples. I mean, why is this in any way representative of the world? And so you just did a little bit of a statistical analysis, and you just asked the question, okay, well, how many people do you think might have these kinds of conditions? And you kind of came up with, let's assume it's 1 in 100. We assume that it's everyone, from what the evidence that we've seen. But let's assume it's just 1 in 100. Now, how likely is it that 4 people that are not related to each other, separate, disparate people, with samples taken at different times over a period of months, what's the probability that all 4 of them would have this type of coagulation and other deformities? So you do that by going 1 over 100 times 1 over 100 times 1 over 100 times 1 over 100, 4 times. And that ends up being 1 in 100 million. So the likelihood that this is random is 1 in 100 million. And if we added, a couple more samples, we'd be 1 in 100 billion. Or if we added maybe 5 or 6 more samples and we found it, it would be 1 in 100 trillion. But the bottom line is, this shows, just with this very simple analysis, that finding 4 random samples shows that this is not a statistical fluke. Okay, it's not nonsensical. It's something that we need to consider very seriously. But not only that, if you combine this disclosure of overwhelming CDB incidence and blood degradation with previous Carnicom Institute research, it must be concluded that we are beyond the point of statistical likelihood. We have a major problem before us, and that problem is the future existence and welfare of the human species. So the bottom line is this just confirms, with coagulation to a greater extent than what you've seen in the past, everything that you've seen, with the exception of the additional coagulation, through 25 years of other research and samples.
That's right. It's an added dimension to the problems that have developed prior to this. It's an added dimension, but it doesn't take away from anything. It only generally makes it worse, is what it amounts to. And also that statistical approach, actually, it was sort of interesting because the end of that thought process was that you can't win no matter how you go about it. That is, if you try to say, well, this is, it's expected to be very common, why would you make a big deal out of this? Well, that already, when you're saying that, you actually are already saying you have a problem, or a problem that should not be there. And if you just advance that argument and you start to restrict it and say it's not common, it's very uncommon, no matter which way you go, you really can't win. The situation should not exist, period, is what it amounts to. Whether you try and interpret that from a statistical point of view or a common sense point of view, it should not exist.
You got a problem, Houston.
Yes.
One thing to note in those slides that we looked at, that we didn't see any of these filaments.
No. That's correct, and that's not any kind of common occurrence in the slightest bit. But the presence of the CDB is actually, it's more than common thus far. This has existed in every sample that's ever been looked at.
And that
to some
fact,
degree.
that fact is going to become that there are no filaments to be seen, or very rarely, for over 20-something years, is going to become quite relevant in future papers.
And important. That's right.
Okay, so here we have blood alteration 2, means and methods. And here you go into a lot of detail about, the methods that you used. And here's some methods which have been used in these current studies. This is just in current studies, and then there might be another 5, 10 or so that you've used in previous research. Electrochemical analysis, visible light spectrometry, near-infrared spectrometry, microscopy, protein detection, reagent-based, enzyme analysis, centrifugation, magnetism. Okay? Then you go into talking about what each one is in detail, but it's written in pretty plain language, so anyone shouldn't be intimidated. But then just under electrochemistry, as I mentioned in our introduction, here's 14 different disciplines in a way, or approaches, right? Approaches that you might take.
That's right.
That might take just under that one thing, and the one that you used most here was a cyclic voltammetry, and there was one other one too.
Actually, AC voltammetry would be first.
Okay, right.
And then the other would be really. It'd be DC voltammetry. Cyclic would be sort of the closest.
Okay.
It would sort of be the closest. There's really variations.
And when we talked about the fingerprint that gets produced when you do this type of analysis, and this is called a chronopotentiogram. So as you move the currents, different magnitudes, okay, you start getting these different types of lines, but you can see that they're kind of shaped quite similarly. But when you start to, and basically this fingerprint, you could look up on charts that are available, and this tells you a lot about what you're looking at.
It's a signature. Yeah, it's a signature. And a common approach in any kind of lab analysis is to acquire something that is unique. You subject a sample to a impulse, a signal of some kind, and you see how that reacts, and you get it recorded. There's many different ways of doing that. Infrared is a real classic way, but in essence, you have the equivalent of electrochemical spectrum here. It's a response of that sample to a signal. And I wanted to mention, the big picture of what's going on here is you had an observation that says this is highly anomalous and it's very troublesome. And really a serious problem. So the whole point of this was then the next logical question is, well, what's going on with that? Can we learn what's going on? What's the nature of that blood? And so this is where the lab analyses method would come up. This is why they come into existence, is to now start trying to get specific information about, well, what's actually going on with that blood.
And we use these various techniques to find out.
Yes.
Visible light spectrometry.
It's ASET.
Spectrometry, near infrared. You go into explanation of which each one are. It's not complicated to understand. Okay, and then one thing that you've done on all these papers is refer to your research papers that you've done in the past that will give further explanation, further guidance, and connect the dots between work that you've done in the past.
And to further demonstrate, these are not isolated analyses that are taking place. There is a progression of historical research now spanning decades, and what you're actually always looking for is consistency within the data and the results. And that's what's happening here. The fact that all these papers are coming into play, they're demonstrating that level of corroboration and consistency between the reports is what they're doing.
And using a whole other different technology to do it. Okay, transformation. This is
so that means and methods. That's the hard data. That's a hard data collection is what it is. You can look and you say you have a problem, but now what are you going to do? What are you going to do with that? You're going to talk about it. In my case, talking produces nothing. What produces are hardline analytical techniques. They give you data about what the state of that blood is. It might not be, how would I say, exciting to people, but it's absolutely the essential requirement and essence of any work that's going to take place.
I think it's called science.
Yeah, that's right. That is what it's
Okay,
called.
so we've got protein separation, microbe identification, and blood transformation in this paper that's addressed. But let's take a look at this. You often do this in your other papers where you start with the punchline. Direct evidence indicates that the application of a low magnitude electrical current can or will transform a blood sample to the point that it is no longer recognizable as blood in any conventional sense, and the nature of the blood is then dominated by the presence of the cross-domain bacteria. Nomenclature which you came up with. Microbial life form and its manifestations. The blood sample examined in great depth is one of those discussed previously within this specific 6-part report. So here you go, one sample, and you really go into a tremendous amount of detail.
That is an extremely powerful statement and point of fact and claim, if you actually read what that is saying and understand what it's saying.
This is the punchline of everything that we're talking about basically today.
Yes, and this is where the word transformation was put into the title. Again, you do not change or transform blood. You don't want to see that. You don't want to see that in the grandest scale that you could ever imagine. And here it's being stated and claimed that this occurred under, let's say, known, identified conditions that can be replicated and is evident. And the claim
very
is to be made.
little amperage, relatively. Very little amperage it took.
Not supposed to happen, okay? Common language, it's not supposed to happen.
Okay, and you use AC photometry, then you use DC, because one of the things you ask is, okay, AC is a little bit more tricky to do, and can we do something simpler that also produces the same result? We found out that we could. And you show here, you describe exactly how much you've diluted the blood using distilled water, which isn't as distilled as a lot of people think.
Correct.
But you had to do a lot of controls just on the water itself to eliminate any of the noise that might bring.
The method is very, again, there's 8 methods in there, but electrochemistry is actually a rather powerful and sensitive technique. It's pretty amazing what it can uncover.
And so one of the qualitative things that you could just observe happened was that there was a segmentation when you put the current through it, and there was this frothy foam-like material at the top, and then there was this red, more dense, material that basically precipitated out at the bottom.
Right, that's right.
And then you became interested in saying, okay, well, what's in both of these things?
That's right.
Let's take a look at both of them. And so this you're assuming is some kind of a protein, right?
Yes, that would be the classic image of sort of protein structure and mass that's being seen. And something that's, I think, important here is to understand, the motivation that was driving the project, this part of the project, and then what happens. Motivation behind this stage of the research is simply to start gathering information about the nature and identity of this unusual blood, right? You're just trying to collect information about the nature of it. What happens is an event takes place during the acquisition of that data that is completely outside the scope of consideration. Never in any way would you anticipate an alteration or transformation of the blood in the process of analyzing it electrochemically.
Okay, so and then we start out even with just the separation to this frothy thing and this blood thing by putting a little current in. Even that itself is quite unexpected.
Well, that is what's unexpected. And of course, you're asking what is happening, because certainly it's possible that electrochemistry, it might alter something. It's possible, but the question is, what was it altered to? And this is what was observed, okay? It was altered to what you're looking at here, okay? And now you're looking at things, there's no way that you can come up with any really logical explanation for why this would occur in any normal consideration of blood. Okay. No way could you ever consider this.
So basically, we're looking at the frothy part of this separation once we put a little bit of charge in there, and we see this stuff, which is indicative of a protein, but also look at all these filaments.
You have filament formation in the blood. you cannot have filament formation in your blood. That's a lethal affair. Okay? You cannot have that.
Now, we also see as we get closer.
Now, this was a previous paper. This is real important.
Right.
That this was a reference. Okay, this was a reference to show you the coincidence, again, of the research. I don't know if we show the date on that paper, but it's sort of, yeah, I mean, look what we're talking
2014.
about.
But in particular, what this shows is the presence of the CDBs, right?
Yes, and it shows the alignment. The whole point of this was to show the alignment that takes place at the early stages of filament formation. Okay. That was
Right. So the point is, in this paper, you go into detail about how this eventually turns into a filament. It's not that obvious from here, but we can see the CDBs, that's for sure.
8 years separation, you have the same structure, same thing going on here. 8 years separation in time, you have the same thing, but one is happening. This is a result of culture work, almost certainly. Okay, extended time periods, a tremendous amount of work and research going into finding mediums that would support this growth. We're talking about comparing two things 8 years apart in time that show themselves to be essentially identical. One has essentially years of research to create it. The other happens within 2 hours.
Right, and these cultures are happening over days.
Yeah, the cultures will be happening, and they do have.
And so what we see is the formation happening from here. This is the same paper, growth progressions.
Yeah, that's right. Both of these.
And that turns, and then when you start to look closer, you see this that came from those CDBs.
That's right.
Okay. And now this is significant because some people have commented that they believe that the filaments is what causes the CDBs, and after years of research, you've come to the conclusion the CDB is the fundamental particle.
You're right. The evidence says you start with the smallest entity, and you work from there, just like anything else that grows.
So now we're back to today, basically, and here's another close-up of these granular structures that are some sort of protein.
Yeah, and you can't overstate it. It says candidate, right? I'm saying this is a specific form that's coming up. We'll get to the point of how we make conclusions that it's a protein.
That it is a protein, but it sure looks like one.
When we get to it. But the fact is, the answer is yes, it is, but that's confirmed through all those analytical techniques that we referred to.
Okay, now here you talk about making a transition to the DC, use of DC, and you end up with this type of a situation. This is very typical. I mean, you can go back to your work and see this type of a picture time and time again.
Correct.
And this is the lower level now, the lower layer. Low level electric current, 1500x, 1500 magnification. And what is this thing here?
By the way, well, that blue color, that's a whole separate topic. That's a very curious affair. That's actually a repeating theme. That particular color, that's not an aberration of the slide. There's a very interesting thing. Right now, the closest relationship would be, it looks like to what they call a Prussian blue dye or so. There's just really interesting things going on about the reoccurrence of that particular color.
And there's no dye added here.
No.
That's happening on its own.
No dye. No. Okay. There are color aspects also.
So anytime there's a color change, it's an indication of a chemical reaction.
Right. Color is a spectral entity, is really what it is.
Okay. And then this is also.
Those are fascinating. That's a fascinating topic right there.
Yeah, we assume it's a CDB-generated protein.
Well, yeah.
And this came off of the lower level? Doesn't say that, but I assume
I don't know that I can speak to that, but my answer would be yes. Recollection would be that would be the lower level, lower separation level. That raises many questions. Okay, already with electromagnetics, actually, even at this point, because you have alignment taking place, and
by alignment you mean the stuff that's in rows.
These have
like this
polarization. They have alignment to them. That immediately suggests possibility of electrical association.
That these things are charged in some way. Okay.
And I'd actually seen this years ago also. I've seen quite a few things that have never actually been, you could write forever on terms of things I've seen. But I have seen this formation in the past. I've actually tried to dismiss it as much as possible. And the reason I showed this is because I saw it on multiple occasions within the slide.
Okay, and just so that people know, like, what would this be here?
Just consider it, how would I say it? Incidental. It's incidental depth of field. It's at a different different planar surface. It has no relevance.
And how about this? How about this
plane.
Stuff here?
Those
and
actually,
here.
if you look at them closely, they are largely it's a combination of CDB and filament, early generation filament formation in it.
Okay. How's that for a filament? That's a lower layer. And you know what's interesting? We should stop for a second. You know, how many times have we seen now, within the last year, people point to something that looks like this and say, "Oh, this is graphene oxide," or "This we found in the vaccine," or something like this. And I keep, making comments whenever I come across this stuff in these videos and so on. Why don't you go back and take a look at Clifford's work of the last 25 years?
There are claims and extrapolations that are being made that to me, are not justified under the rules of science, and are not have not applied consideration to the historical database that is available to them. That was a very diplomatic way of saying that, wasn't
Right.
it?
Yeah, it was.
Yeah, it was quite mild. And it's unfortunately all rampant and common.
Right. So here we have alignment of what we believe is the protein, and this is probably from the lower also. But the thing is, we're seeing a lot of what's in the upper and the lower, and what's in the lower and the upper.
Yeah, and we'll find ultimately that chemical constitution to the level that I can determine is highly similar.
Right.
But there is obviously some kind of difference that's occurring with respect to density because of the separation of them.
Okay, so more pictures indicating this.
By the way, on the foam issue, that was interesting in terms of this frothy material at the top. That was an interesting question because, the classic case of foam, I came to the point of asking, well, where does foam come from? Because a common picture is foam on the stream, right? That's and soap suds, whatever. So I looked that up, and it was interesting because that's what I know of. And the papers I found, they said there's two sources, and they say pollution is one, and the other is protein. And the protein was actually new to me in terms of consideration. But if you find foam in a natural environment, those are the two most likely sources. So you're going to say the top of your list is going to be, okay, polluted blood. What does that mean, right? What would that mean? Or protein in the blood. What does that mean, right? Foreign protein. We know we have hemoglobin.
So here's a filament. You have hundreds, thousands of pictures like this over the 25 years that you've done your research. But how many times has somebody pointed to this recently and said, "Yeah, this is from the vaccines"?
Yeah, I would seriously say that work at this point does not satisfy the standards of the scientific requirements.
You've said that already, and you mentioned how that was diplomatic.
Yes.
Okay, so. That gives an overview of this.
So these are pattern repeating patterns, repeating formations. I do things many times, and they're not supposed to be there. And they all indicate a radical transformation of the nature of the blood, and blood will not function. The services of blood will not be provided in that form.
Okay, so it's important to know this is just blood and some distilled water. You're putting a charge through it. It separates into this frothy component, this darker red component. You start looking at both to say, well, what is it? But also what we're finding is that the blood cells, the erythrocytes themselves, are kind of disappearing and turning into other things.
I use the word transformation because the blood is no longer recognizable. Now, blood in water by itself, those cells will burst, okay? I'm quite aware of that process. That's not the same as what we're talking about here. You can prevent that, by the way, with saline solution osmotic balance. We're talking about the formation and creation of identifiable unique structures, which ultimately are known to be life forms. This is what they are. They're life forms. This is not just some chemical construct.
It's taking over.
This is a life form.
Taking over.
This is a life form I use the word dominate, right? That now dominates the nature and existence of that blood when subjected to the current. That indeed qualifies as a transformation of the blood. It is no longer blood.
Can't be more clear about this. Okay, so here you start looking at the protein itself. There's various methods that you've come up with. This is voltammogram using AC power here.
Yeah, that's a typical profile.
And that's a profile
and that's
like
numerous
we looked at
runs.
before.
That involves numerous runs, quite a bit of time invested in that one set.
And each one represents a different voltage, right?
Your voltage is on your horizontal
Okay.
axis. It's a point in time is what it is. It's a point in time. That's
So it's the same
elapsing of
voltage.
time.
No, there's voltages that
Voltage
vary.
is going to vary. Okay. Voltage is going to be. Time
Over
is going to
time.
be a factor, right? And then the current, you got three things going on there, right? You got voltage, you've got time, and you have current.
Okay, but this gives you a distinctive signature that you can then go back and find out what is actually there.
Yeah, every nuance and variation in those curves of any kind, however slight, is a signal and a telltale identifier of a chemical, really a chemical reaction and ultimately a chemical species. That's what that's for. That's why you're doing it.
And more inorganic than organic?
Yes, electrochemistry is more applicable to inorganic analysis, although it wouldn't be completely restricted to that.
And so you go into quite a bit of detail here about the methods. You're using graphite electrodes, two sets of current profiles that do the reversal in current polarity. So that's why we see that one is going up and one's going down.
Yeah, these are
in terms of the
reverse
curves.
polarity, right?
Blood samples, dynamic environment. This is important. That's part of the reason we're seeing some changes. It's the blood's moving and changing. This is living blood. It's in water. It's not a dry slide. Might be 10 to 30 electrochemical profiles within a typical analysis. 3 to 10 minutes for each one. So you're putting in that one slide of that graph represents huge amounts of work.
Probably 2 to 3 hours of work.
Huge amounts of work. Repeated on numerous occasions. This just wasn't a one-time deal. It was replicated. One of the key things in science to prove a point. A lot went into control samples so that you took out the noise that's involved with distilled water, which ain't as pure as most people think. The methods developed.
As well as reference to known proteins. That would be important in terms of control work.
Right. And here we have, we're down to parts per millions in terms of sensitivity. Concentration is an important factor. You've got this thing tuned so that even very low concentrations can be detected. Changes can be detected from very small concentrations in solution.
Right.
Part of what we're doing here is we're trying to figure out what we're looking at is oxidation reduction reactions.
That's
to a
the
large
heart.
extent.
That is the heart of electrochemical.
Which is basically involving transfer of electrons.
Yeah, that's right. Redox reactions are a crucial form of demonstrating energy exchange in a chemical or biological environment.
Which means electrons.
Which means energy flow.
Right, both. Okay, and you're looking at any changes that happen in these curves. Repeatability is important. And what chemical species are there, and what kind of proteins, if we can get more information about that. The comparisons here were done with lots of other analytical techniques, which we talked about at the beginning, that you used here, never mind what you've used in the past. And you make a reference as to where you can find those. Okay? Now, in the foam precipitate up top, you're finding out from this electroanalysis and the fingerprints that you've got, these identifiers, this is stuff that you're finding.
Yes, that's right.
Okay.
That's right.
And then when you take a look at the settled layer, you're finding very similar stuff as well.
Yes, yeah, that's right. There's a pretty high level coincidence between those even though you have different physical appearance of the sample, chemically they
very
come down
similar.
pretty similar.
Okay,
Yeah.
and there is one very interesting thing because you're finding this hydrozoic acid, which you have never found before in your previous work.
That's right. That was outside the history of the previous research.
And we'll go right there for a sec because for every one of these topics, you then go into a discussion about what it is, and you have reference papers about where you've addressed this in the past, the halogens, the oxidation products. Look at all the papers associated with that,
papers.
right? Yeah. Okay, so you can spend the rest of your life looking at this if you want to. But it's a colorless liquid at room temperature and pressure. It's toxic and is recorded to produce the following effects at 0.3 parts per million. Under inhalation, produces structural functional changes in the alveoli and bronchi. Sounds like a respiratory problem.
Right.
Causes changes in central nervous system. Oh, gee. It causes changes in cardiac rate. Jeepers, those are things that people are talking about in terms of what's going on because they got jabbed.
That's right. And if people were willing to look at it, you cannot help but find a high level of coincidence in the symptoms and toxic effects of the compounds that I am identifying in the general state of health of the human species.
And this is being done kind of between minus 3.33 volts and plus 3.33 volts.
Yeah.
That kind of range you're getting this
Now
information.
outside 3 is a little bit unusual. That's why that one is sticking out as being a sort of an unusual finding. Most things will be between 3 and 3, minus 3 and 3.
Okay, so this one showed up at minus 3.33.
Yeah, it's outside the range a little bit.
Okay. So go into the electrolytes, you talk about the metals, and again, here's all these reference papers that refer to the past work. Morgellons, a thesis, which I didn't really mention in the introduction, but I will mention it here now, that one of the things that you discovered in your work was a direct identical correlation between fibers that you were seeing from the environment when you did your environmental samples in your research and the filaments, these fibers that you were finding in the so-called Morgellon sores, which is a manifestation of Morgellons. It's not just Morgellons because we've come to view Morgellons now as a blood disorder, as a metabolic disorder, not which exemplifies itself in terms of these sores and the appearance of filaments, correct?
Right, but truthfully, it's a systemic assault on the entire human body. Is what it is. It's a lame injustice to try and isolate this to some type of skin or just blood condition. It involves a systemic analysis and assault on the entire human health. And what you're saying is true. There's a core finding years ago, quite early, and the paper there was called an environmental source, and that's where the coincidence of the environmental filament with the biological filament was established without any doubt. Really, that was quite some time ago. To view any of this work as some type of isolated event that's sort of interesting to look at right now totally misses the picture. You've got a record of 25 years there. The record is completely consistent. It's very deliberate. It's very persistent, and it says the same thing from the very beginning. It says where things came from. It says how widely they're distributed. It says where they're expected to be found. It analyzes them for what their expected effects are going to be upon, I don't personally just think of human health. I think of life of the planet. People have a focus on their own species. But it shows the effect that is likely to be occurring with the entire biology of the planet. And it pans out to be true, is what it amounts to. That whole progression is doing nothing but panning itself out to be entirely true. And then it evolves to the state where we're having, I'm sorry, but what does something have to be in terms of its importance to you to start recognizing
We got a problem.
your existence is at stake. When does something become important to you? I still don't have an answer to that question in terms of other people. I know that I was concerned 25 years ago.
Sure.
Okay, but this is not an isolated event. This is a capstone of research on a legacy and history of research that is entirely consistent in terms of what it's saying. The flags and the warnings and the alarms that are being put up are all there from the very beginning.
Okay, you go on, talk about phosphoric acid, which is actually quite interesting. You found out that phosphorus, I believe it was, became quite a critical element in helping your culture work, right?
Yes, absolutely. Yeah, it was a turning point in the success of the cultures.
See, and again, all these papers. Now, using infrared analysis, you're able to identify these functional groups, and you spent a lot of time in the past on this whole functional group thing.
And that flips over to the organic side. This is where you flip over to the organic side,
Okay.
primarily.
And these symbolize various functional groups that are that in organic chemistry. So don't get too occupied with that. Some of this is a little bit clearer: carbon, hydrogen, 3, and so on. But what's interesting is, while there may be a priority difference in terms of the amounts, because these are listed into the most prevalent in the foam layer and the settle layer. Look, you got that there, you got that here. You got. Hold on, let's move this up a little bit. You got CH here, you got CH here. AR here, AR here. AROH here, AROH here. ARCH here, ARCH here. ROH here, ROH here. You've got RNH2 up here, but doesn't seem to be here. I think, unless it's
They're fundamentally the same. Is the conclusion?
Right.
They're fundamentally the same, and not to belabor the point of functional groups, because people would need to look at the previous research to get into that question a little bit. But these are identifying signatures of organic chemistry, meaning life form chemistry, and they tell you something. They tell you things, okay, about the nature of a material. And the nature of that material is very important. It's going to determine how soluble something is. Whether something is water soluble or not is going to be crucial to whether it's going to get distributed in your blood, right? Or it's going to store up in your liver as a fat or an oil. That's all information that is inherent within the determination of those functional groups.
And then you go and talk about each one and the significance of them to a small extent. You have papers on each one of these things. And then you look at, do we go into enzyme analysis or not yet?
Yes, it does. Yes, it does. See, this is where I make an important. Now, this is actually an extremely important aspect of the work, because what I'm sort of leading to here is that, okay, you have proteins in your body, in your blood, that shouldn't be there. You have foreign proteins, harmful foreign proteins in your body and in your blood. Well, on a general level, you can start to ask the question, what might I do to assist in the removal or breakdown of those proteins, okay? And it's just sort of like setting a hook or a little bit of a bait, saying, there's an issue here to look at, folks, because the reason that you digest your food, the reason you can exist is because you digest your food. Enzymes are what make that happen, okay?
Enzyme is an organic catalyst. So
Right.
basically it's critical in terms of making a chemical reaction happen.
So if you want to break down proteins, which is what your digestion is, you need enzymes. So the question that arose here is, well, I have proteins. And not only can I demonstrate the existence of those proteins, but also the serious, interesting question is, could they be broken down, or could the process of breaking down be assisted with the use of enzymes? And the thesis was established, it was acted upon, and the results are positive in that sense. They absolutely are subject to the influence of enzymes. It further proves the existence of proteins. It also gives us a lead as to how we might try
Maybe
to
there's a cure.
reconcile with. Yeah, they want the magic bullet, but an assault on the body is hard to deal with. But nevertheless, it's worthy. And I have written a great deal about amelioration steps that we can take to assist ourselves. Some of them I have not even written about. But that was an interesting topic. Do they respond like other proteins do when subjected to enzymes? And the answer is yes, they do.
Then you go and take a look at, what sources of current are there in our world that could possibly help facilitate this not very nice reaction that's happening within our body.
Yeah.
And this is quite a fascinating paper.
This was the unexpected paper. I actually never had plans to write this paper, but the data that came out forced it to be written. I had to write this paper to give a more complete picture of the connection between something most incredible in terms of what happens and then the real world situation. Well, how does this affect us? And could it even affect us? Why should I care about this? Is this, this is some interesting article that blood can be transformed with current. What's that mean in my life? So the question is, well, is there any current around you that might be introduced into your blood? That was the question. And I was forced to write this paper, and you take it from there, but I was forced to write the paper because the question needed to be answered. Are there viable sources of current in our environment that could be introduced in the human body?
And here's just a dozen potential sources of electrical current to consider. The body itself, motion of a conductor with a magnetic field, so basically moving through a magnetic field, and there's magnetic fields all around us as well. An artificial lower ionospheric layer combined with electromagnetic propagation. This is referring to all the work that you did in terms of the spraying that basically brings the ionosphere down lower.
To help people out, to let them know, there's 14 of these things that came up. And it took a little bit of thought, but not too much, and the work is not exhaustive. There's 14 of these totally separate identifiable methods and means by which it's plausible that you have current that's going to be available around you to enter your blood.
And these are pervasive.
These
everywhere.
Look at what they say. There's 14 of these things.
Okay, ground wave propagation, and on and on. And then you go.
Can we back up to? Oh, hold on. Can I look at 14? Just out of curiosity. Right. Can we read 14 as just sort of another point of interest?
Well, as a hypothesis, electromagnetic modification of human biology, e.g. vaccine technology, pharmaceutical injections, biological experimentation modification, genetic modification. So, we know that people on YouTube show where they have magnets that are sticking to them at the site of the injection, for example.
I'm telling things that you need to be looking at, folks, because those previous were primarily in some kind of environmental sense. This number 14 is saying these are things we're doing to ourselves as a species. Sometimes with let's say many times without permission, without consent. These are things we are doing to ourselves by our own direction. And that's deliberate. That's a deliberate injection into your body that you're talking about that has the same potential as the other 13 above it.
Okay, and then you go into each one of these.
And I get to ask, is that okay with you, right?
Then you go into each one of these things. This is significant. A factor affecting current levels in body is concentration. The blood sample examined electrochemically within this report series was diluted in water in the neighborhood of 100 times. This means that the current levels required to produce blood change may actually be much lower than the 1 to 2 milliamps recorded. Maybe on the order of 0.01 to 0.02 milliamps. Okay?
Correct. Microamps are in range here.
So lower currents for proportionally extended times. So in other words, you could have lower current for a longer period of time, it could have the same effect. So the forces required to transform blood may already be within the inherent electrical nature of the body. External sources might not be needed.
That's an interesting statement, isn't it? You may not need to go anywhere.
Right. We can also see that power changes in the body from physical activity levels alone could easily produce current changes. So basically, as you're exercising, you can go from producing 80 watts up to 2,000
Yeah,
watts.
the athlete
depending on
thing
the
is
level.
quite interesting.
Right. So you have athletes dropping dead.
Little sidelight of interest. Yeah. Is there any attention that should be placed with athletes with any kind of increase of unexplained death?
Right. So here we go. This little video here talks about, okay, when you take a conductor, which is a human body, for example, and move it through a magnetic field, electrons start to move. Okay, which means that there's a current.
So I go through all 14 of these,
That's
if
right.
I remember right.
You go through all 14. I'm just showing them. Every
Right.
one, you can go back and take a look in more detail what each one is and how it might affect. So
What's
here,
the actual mechanism, right, of each force?
And here's an application of electromagnetic wave to the human body. There are a variety of sources to help us understand the radio frequency energy can effectively propagate in the human body, and that certain frequency ranges will be more effective than others. The energy would effectively also be able to increase the current levels in the body. This is radio signals. Just one example. And you talk about Becker's work, very, very instrumental, that he spent a lot of time looking at the impact of electromagnetic energy on the human body, and you do some good quoting there. Practical question is this whether the ambient EFM soup that we find ourselves living in already sufficient to induce the blood transformation witnessed to exist. This is, again, just one of the 14 of many more, probably, that we could find. Okay? Cyclotronic resonance, which is a very specific phenomenon. It's a little bit esoteric, but you go into quite a bit of detail in your own papers. You can go online and look up what is cyclotronic resonance, and then you've got a bunch of papers that refer to that. It's actually quite a fascinating topic.
It is.
Ground wave propagation, electromagnetic field, and so on. You go into detail on that. Tropospheric ionospheric ducting propagation. That's quite fascinating in itself. These are all things that you've explored in detail in your previous work. You're just giving little summaries of what these things are.
Some of them are let's say, examined in greater depth for the first time because of the need here.
Okay. Ambient ELF, that's extra low frequencies. And one of the things that was fascinating in your work was, the Schumann resonance, which is supposed to be the resonance of the planet, is 8 point something.
7.8 hertz, yeah, 8 hertz roughly.
8 hertz roughly, okay. But you were finding 4 hertz, which was almost a whole octave lower than what this was, which means somehow that's being generated synthetically, you might say as a harmonic, but as a harmonic that's even lower than the most fundamental resonance that the planet's supposed to have.
That's the plausible hypothesis that's put forth. That is, where does it come from if it's bigger than the Earth?
Okay, and then a bunch of papers there.
Years of work and scores of papers, or at least dozen or more papers were written on that topic.
Motion of a magnetic field with a conductive environment. Okay, this is where we're a magnet going through a field as opposed to electrical field going through a magnet. And you talk about that, referring to Maxwell's equations and how that's significant. Direct laboratory evidence of electromagnetic influence upon cross-domain bacteria. This is where your previous work showed that, hey, electromagnetic energy does have an influence on CDB growth. Primary of that work was twofold. First, to determine if ambient ELF, the extra low frequency field at a fundamental 4 hertz discovered in previous years, remained in effect. Second goal was to establish if electromagnetic fields had any observable effect upon the CDB cultures that were under development. Yup, they sure do. It did have a significant observable effect upon culture growth. The effects were primarily of growth enhancement versus growth impairment. A fairly wide range of frequencies was studied. Okay, so this is another way to confirm that electromagnetic energy helps this thing grow. Satellite propagation, okay, with Elon Musk satellites up there, plus all the other thousands of satellites up there beaming electromagnetic energy to the Earth. more information there, and electromagnetification of the human biology through vaccine technology. You put forward some hypotheses here and things to look at. Is the current agenda and regime of vaccinations delivered under duress to the global population altering the electromagnetic nature of the human being? A very interesting question, because maybe there is a connection between what they've been spraying up here and what they're trying to inject in here. Maybe a very fundamental connection.
My work predicts that there is an expected relationship.
And, the fact that there are these other things that are happening that you've also observed, increased magnetism, clotting, cardiovascular issues, unexplained sudden death increases, which could be explained by those other things, insurance reports on mortality increases, mortician reports on arterial and vascular growths. So you start taking a look at these things that we're getting reports on. At the very least, we must admit to a pattern in place and good cause to justify the inquiry into if there's a connection. At this point, I suspect that the campaign to induct the population into unsubstantiated and untested health therapies modifies human electromagnetics. It is entirely reasonable to question if such charge is sufficient to transform human blood. It seems to be from all these symptoms that are being reported. Okay, that's what that paper is.
I'm very grateful for your familiarity with the work. Obviously, that's an investment on your side that you made. You are basically reaping the benefits, basically, of that investment with your understanding. And it's a huge commitment. And I realize that people just are not attuned to being able to make that kind of investment in their life. But I'm grateful for yours that you have made because it gives you an understanding, I think, of the significance and importance of what is available to us to understand if we wish to. And I appreciate that very much. The request that I would have, if it's possible, is this last paper. It's short. I guess I say short and sweet. There's no science in here. If that bothers you, if science bothers you, there's no scientific presentation to you. It's more of an editorial. I'd actually like to read the article if we have time, because I think it's only a page. And I have tried to summarize the essence of everything that we have been speaking of here, and also, in a sense, encapsulate the entire body of work that precedes it over 20 to 30 years. And if I was able to condense its potential significance into one page, this would be it.
So there's three pages, but I've highlighted a couple of things. Let's see if this does the trick for you.
Yeah, if you're able to read enough to do justice to what this paper is trying to say, I'm hoping that it will be a benefit, because it's not about the scientific argument at this point. It's about the existence of the human species, is what this paper is
And
about.
you've introduced two terms, kill switch and selective decimation, with lovely terms. There is now a record of more than 400 research papers, along with estimated 5,000 pages of laboratory notes, that paints a completely consistent portrait of environmental and biological transformation of this planet. The record has been available for all to examine, repeat, refute, or confirm. No formal process of these steps has taken place, and we are left, together as a species, to frame our understanding of what has taken place and what shall take place in the future. From the evidence that has progressively accumulated, it would seem that delivery of sufficient current, apparently quite minimal, into the human race on a global scale could conceivably annihilate the human species. The mechanism would be the transformation of the blood as outlined in this paper series. We may not wish to entertain the prospect within the comfort range of the human psyche, but I would argue that we must. Circumstances have been unattended now for far too long to escape the prospect. Although unwitnessed in our human history, a global electromagnetic pulse of sufficient magnitude might be one mechanism of such distinction. A coined phrase of selective decimation could be kinder to the human species. In this case, we have a full range of lethality to apply, be it in an individual, selected individuals, or select individuals, a group, or a global population of mass. So you can aim where you want to create havoc. This process can actually already be operation. It's doubtful that it could be easily identified or even known. It is in operation. We know from lots of other things. And if you want to spend a little time with Alana Freeland's most latest book, geoengineered transhumanism, you start to see a lot of evidence for how this all is in play already. In popular lingo, I suppose it could be characterized as a perfect whodunit scenario. No one need ever know, and the only sign to attract any notice would be an increase in the mortality rate, which is likely to become simply another information management issue, which of course we know has happened. Overall mortality has increased. Unexplained increases since the vaccination. Unexplained increases in sudden deaths, the cardiovascular mortality, autopsy anomalies, or unusual actuarial or insurance reports might be other clues that are present. Well, they're there. There's already reason to think that such change is in place, but it apparently remains undeserving of special attention. Is that enough of a summary to get the message across?
I hope so. People will judge. The question is, do they have sufficient interest to engage in the topic subject further, or really engage in their future, honestly, further.
So those are the 6 papers. And this is quite a telling photograph from Space Odyssey 2001. And now we've gone through the effort, we've gone through the expense of putting this out there in this form,
Yes,
so that's a little bit more comprehensible and accessible.
Yeah, thank you.
And so now it's up to you.